Hello, and thank you for taking the time to watch this video. My name is Uriah Moeller, and I'll be narrating this slideshow. The other members involved in this project are John Williams and Mengistu Shuma. Together, the three of us developed Prospect, an addiction risk modeling application. The question behind this entire project is this: what if you could predict your addiction? The United States is gripped by an opioid epidemic. As seen by this graphic provided by the Department of Health and Human Services, in 2018 and 2019, more than 130 people died every day from drug-related overdoses. What's more is that 10.3 million people abused opioids that were prescribed to them. But why is the abuse of prescription opioids so important to distinguish? Clyaxa, the company we worked with, develops an application which gives patients the ability to communicate their medical data directly to doctors and care teams. From patient-reported assessments, doctors are able to prescribe medication without having to be there in person. Their goal was to have us develop an algorithm that could take these patient-reported assessments and then determine the risk of said patient developing an opioid addiction based on that data. A patient who reports problems at home and severe depression is likely more at risk of abusing the prescribed pain medication than someone who reports the opposite. However, this information needs to be processed and examined across larger pools of data before a conclusion can be made, which is where Prospect comes in. Our overall design requirements were to create a self-learning algorithm which could take 7 clinical assessments as inputs and then generate a prediction on opioid addiction risk. Additionally, we would create an application to simulate end users, doctors, medical professionals, etc., interfacing with the algorithm to generate on-the-fly patient risk assessments. For our algorithm, we used a deep neural network. Broken down to its core, a neural network is comprised of layers of nodes, where each node acts similarly to a neuron in the brain. Given an input, it determines if it sends the data forward to some, all, or none of the nodes in the next layer. This continues until it reaches the last layer, where a result is produced. By feeding enough data through this network, we can train it to produce more accurate results. We can then repeat this process over and over until the accuracy increase rate plateaus. As the network code handles this process itself, it is considered self-learning. Prospect as a whole is a simple application. We take patient data, store it into our database, send it through the network to process the data, and then display this processed data to the user. The processed data is then stored back in the database for quick retrieval. The technology used to create Prospect is widely used and well documented. For data storage, we use MySQL database. For handling both the creation of our neural network and the process of training it, we use TensorFlow, perhaps the most popular machine learning framework available today. And for our code base, we use Python 3, an easy-to-use and quick-to-deploy language that interfaces well with TensorFlow. We encountered several challenges in developing Prospect, mainly related to how to correctly process this data. The beginning of the project involved much discussion about which type of neural network was most appropriate for what we were attempting to accomplish, what data is worth keeping and what data should be ignored, how to reduce the dimensions of our input data to better process it, and how to classify results so that they are understandable by end users. Here's a small demo of our application. Here, I'll be generating a new patient risk assessment. You can see there are 8 fields, 1 for the unique identifier for the new patient, and 7 for each clinical assessment. After entering a value for each assessment, I can click this button, which displays a report determining that patient's risk. As you can see here, this patient is at a high risk. I can also search for this patient using their unique identifier. From here, I can bring up their previously generated report. As you can see, this is the same report from before. Testing and mitigation for our development process was very quick. Through testing, we discovered no functionality issues with Prospect whatsoever. In fact, our only issues were due to poor instructions relating to the debug menu, an aspect of the application that was only necessary for testing. Mitigation involved improving our instructions and also updating our report layout, as you saw before, to make it more appealing to users. We completed the transfer and handoff of Prospect to Clyaxa on April 24th, where there were no major issues encountered during the process. After guiding Clyaxa's senior app developer through the installation and usage of our software, Prospect was officially in Clyaxa's hands, marking the end of this project. As the three of us started this project with no machine learning background, this has been a tremendous learning experience, and working with Clyaxa was fantastic. We hope you enjoyed our project. Thank you for watching this video.